I'm Ken Gray. I am Chief Performance Officer and co-founder of DIG Robotics.
That's awesome. So the name kind of like starts to give it away. So if you had to, write a one sentence blurb about DIG Robotics, what do you guys do?
We are the intersection of kinematics, of 3D scanning and machine learning to help operators perform far better than we ever imagined they could.
So what's wrong in the industry today? So what is it that you think is both on the utilization side, like both on the customer side, and that I guess is going to be the focus of our conversation when we talk about what you're building right now. But I also want to ask you if you think there's something else that needs to be fixed. It's like a prime issue for big OEMs like Cat.
And I think I may have said earlier that the price of dirt, I've said this a lot, I say this a lot, the price of dirt hasn't changed in 100 years. If you look at, if you think about, things that have not kept up with inflation, the price of moving a yard or a cubic meter of dirt has not kept up with inflation.
So how do you think of, how do you segment and help understand people that don't know anything about the excavation market? How do you help them think about the market? So
yeah, it's a great question. I'll tell you the mistake I made in the beginning. The mistake I made in the beginning was that it was related to the size of the machine, right? And the way we are organized, the way most companies are organized is around the size of the machine, right? Because it's a design manufacturing synergy that they're looking for, right? You don't want to run a 90-ton excavator down the same assembly line that you run a 7-ton excavator down it. So there are size synergies.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hi, Ken. Welcome to BitBuilders.
We're laughing before we even start recording. I think that's a good sign.
It is a good sign. And I think it's really interesting if you started out, but by just, introducing yourself really lightly, and then we'll get into, who you really are.
I don't know if we've got, people may not want to know. I'm Ken Gray. I am Chief Performance Officer and co-founder of DIG Robotics.
That's awesome. So the name kind of like starts to give it away. So if you had to, write a one sentence blurb about DIG Robotics, what do you guys do?
We are the intersection of kinematics, of 3D scanning and machine learning to help operators perform far better than we ever imagined they could.
And what's the industry of reference that?
So we're talking about excavation machines, anything that has a bucket or a blade on it. There are about 10 million of these machines operating worldwide. We measure the operating costs on an annual basis in the billions of dollars for machines doing dirt moving, primarily, dirt and aggregate type of material. And then I think one of the things just to kind of characterize the size of this, we think of commercial aviation as being something in terms of greenhouse gas emissions that we need to really get a handle on. Excavation machines produce about 50% more greenhouse gases worldwide than commercial aviation does, to just kind of characterize the fuel burn, how much energy is being used.
And it's a staggering statistics. I mean, if you think about it, but from a first principle physics perspective, it's really, you just have to lift a lot of heavy stuff many times over and inefficiently, right? So that's the the type of physical problem that we're dealing with. But I
Exactly.
really want to get into that because I think you're going to have a ton of insights, pun not intended, on the weighing scales. But I'd love to understand, how does one get to that, right? So, we have met last week, and you gave me a little bit of an insight in what your lifetime, career has been. And I'd love to, get a handle on what did you do? Where did you grow up? And where did your career trajectory take you? So that's that's the type of stuff that I would want to start as a blank check, and then let me interrupt you here and there to dig down into future curiosity.
Yeah, no, I love the sound of my own voice, Gabe. So you have to shut me off once in a while and get me to pause, right? I grew up in a farm community in the middle of Illinois, maybe 200 miles south of Chicago. And when I was a little boy, they were building the interstate highway system through my little town. In fact, I remember riding. There was a giant hill that I remember racing my bicycle down, or my dad would drive too fast because we were, like I told you earlier, I'm not a climber, or I wouldn't jump out of a perfectly good airplane, but I do like to go fast. And they converted this area they used this valley that we used to ride through as the bypass around my hometown. And I remember watching construction machines, scrapers, 631s, which are a single engine pull, scraper body, wheel tractor scraper. And they had the big push block on the back. So they're being pushed by D8s. And I fell in love with the sculpting of material and, putting it into a position that, made our lives better. And, I think I probably mentioned, I remember vividly sitting on I'm going to give the date away too, probably. I sat on my gold metal flake banana seat, high rise, handlebar Schwinn bicycle on a hill, literally sitting on a hill watching that. And I fell in love with excavation. And that's, I came home from second grade, told my mom, I'm going to go to college. I'm going to be an engineer, and I'm going to design machines to do that work. And she says that I specifically said engineer, specifically used the word design. There's no way. But I did say Caterpillar.
That was already your target company.
That was Target. I was seven. I was going to work for Cat. So that was that's what I ultimately did. I was privileged to work 33 years at Caterpillar and develop excavation machines, primarily hydraulic excavators for the vast majority of my career.
And what's the, okay, so this is a really niche engineering area, right? Like, this is not a common one. And
no, I know.
The one thing that I really want to try to understand, because you've been in that company for so long, how did Cat manage to hold such a relevant position for so many years? What's the history of the company there? And how does that connect back to your trajectory within it? So where was Caterpillar when you first joined, and where is it now, or when you left? How did that company evolve? So
it's really what an interesting question. I mean, so Caterpillar I've been away for almost 10 years now. By the way, I retired at the end of 2015. And so I look back on Caterpillar with quite a bit of nostalgia, I have to say. We are celebrating 100 years this year of Caterpillar, which is great. When I joined the company, its top line for the total company was about the top line of the business that I managed before I retired. So Cat's top line was probably, 2 billion, 3 billion, something like that. Maybe more than that. But, the large excavator business that I ran, starting in 2009, that was the top line of that unit, which was part of the excavator unit. So, the company was 10, 20 times larger in 2015 than it was in.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
1981 when I first started working there. But I think it's always had such a dominant position because they recognized very early on that they needed to keep customers' requirements in mind. I mean, this whole idea that, we knew that they knew early on these machines were going to be in very difficult environments, that they had to perform well, that they had to be extraordinarily reliable. But that they also knew that they weren't going to be able to support every machine everywhere in the world. So I think the establishment of primarily independently owned dealers around the world and that whole network and parts availability and service capabilities, I think that combination of the parent company focusing on let's deliver everything we can about customer to serve customer needs, and then the local presence of these dealers around the world, I think is what drove, really, and still today, I think, most people don't realize that Caterpillar dealers have more capital invested in the business than the parent company does, and more employees than the parent company does. So I think those were our formulas for success. And then I grew up across the street. My best friend growing up, his grandfather was an excavation contractor, an excavation and demolition contractor. And I remember him saying that he owned nothing but Caterpillar equipment, except case backhoe loaders. And he said, and I remember he saying, if Cat made a backhoe loader, I'd own one. And that was way back before Caterpillar made backhoe loaders, obviously. But every piece of equipment he had was Cat. So, I mean, I got it naturally, I think, through osmosis from Steve's, the late great Steve Skank's grandfather.
So where did you start? So first of all, actually, let me preamble that. I think even growing up in Italy, right, which is not one of those countries where you have construction density, that you would find in the United States or in Germany where I live now, or in the Netherlands where I used to live, which is insane. Like you walk around, it's a big construction site. Amsterdam is a construction site all the time. It takes a huge maintenance effort to keep a city that it's under the level of the sea, right? So you see Caterpillar equipment everywhere, right? In every single corner. Yeah. Even in Italy, same thing. It's become a household brand despite not being a household product. So that's how powerful that name is. And what I want to try to understand is, so what year did you join? So if my math is right, at 85.
Yeah. Well, I joined and then I left. Okay. So I joined in 80, and then there was a huge downturn, and I was a very young, didn't have my engineering degree yet, and left. And I went to work in an aerospace company, which was TRW Space and Technology Group, which is now part of Northrop. And then one day got a letter, hey, would you like to come back to an interview at Caterpillar, which I thought was funny. And I'd been there a couple of years, and, I come back and interview. And I did. I mean, the aerospace work was interesting, but I didn't think, if you're a mechanical engineer and you're trying to make equipment live in the dirt and rock, that is a tough problem. And to me, that was the most fascinating problem. And so I wanted to get back to those types of things. And so I went back after a couple of years away, had earned my degree in mechanical engineering at that time, got back to Caterpillar, went to work, at the Tech Center, which was a cool place to start. It's like a big college campus there north of Peoria, Illinois, and started to work on my master's degree, like almost right away. So they supported me, and, helped me get my master's also in mechanical engineering, during that time too. So yeah, and then it's just, then I couldn't hold a job after that, Gabe. I went, I was in Peoria for 5, 6, 7 years. And then they asked me to move to Japan, to teach. I was a structures guy, structural design, vibrations guy, finite element analysis, loved the structures, work. And they asked me to go to Japan to work for what was then the Caterpillar Mitsubishi Excavator joint venture. And my job was to elevate the design, specifically the structural design capabilities of the team, which was primarily Japanese, engineers in, west of Kobe, Japan. That which was so again,
That's
and then they moved me so many times after that. I mean, my children say they went to elementary school in Japan, middle school in Belgium, high school in Chicago, and then a university in the US. So they don't know. If you ask them where they're from, maybe kind of like you, they don't know how to answer the question. You know, their native language is English. That's all they would probably tell you.
That's all about the roots that they got. But
yeah,
but on the other side, they lived in a bunch of cool places.
They did. They really did.
That's for sure. And so you started already in the excavator business of Caterpillar, designing components.
Yeah, well, I started working as a support guy. So I did, finite element analysis was my master's thesis, and you know, that structural work. I still like it. I still think that's cool work. And so one of my first job was developing software around finite element structural analysis. And then I was the kind of one of the 2 or 3 company go-to guys if you were having a modeling problem and needed some technical support to fix it. So, that's where it started. I mean, I started working on that. So I worked on everything. I worked on dozers. I worked on backhoes. I worked on engines. I worked on valve trains. I remember a valve train slipping problem on 3500 series engines. I worked on all kinds of things and became known as a problem solver. So, you know, Ken is going to fix this. And then when I moved to Japan, I got a little bit bigger problems to fix. And then when I went to Belgium after that, I got a little bit bigger problems to fix. And that was when they asked me to run a business for the first time toward the end of my assignment there. And then they moved me back to the US and gave me a little bit bigger problem. And, you know, pretty soon they were, $1 billion problems. I ran the small excavator business worldwide as a director for building construction products, which was about $1 billion top line business thereabouts. And then I ran, as I mentioned earlier, the large excavator business worldwide, which was a $2.5 billion top line. And then I was appointed as Cat's first, what most companies call a chief innovation officer. Cat called it a director of innovation. And I don't know how you direct innovation. I always struggle with that title, but that's what it was called. So, and then I retired in 2015. So that's the journey. But I think it all gets back to the love of watching. I am still that little boy in the sandbox pushing dirt around with the palm of my hand. I just thought that was really cool. And I love the interstate work. And, a lot of people think of construction, when a lot of people think of as the start of construction, we've been there for a while. We showed up to the green field and we opened up the green field and we took it to its, the shape of the location to its near net shape and got it ready, for what most people think is the beginning of construction. But for me, a lot of times in urban environments, like where you are now in Berlin, it begins with demolition. So it's demolition, excavation, and then we get into the beginning of construction.
And so so first of all, incredible career. Only one of the few people I imagine out there that has seen really just the development of the back office, what it means to develop such a great, difficult to, operate, difficult to engineer, difficult to repair machines. Like these are the machines that are keeping our infrastructure alive. And people don't really realize that. They think, these are just the machines that are blocking the street and not allowing me to go through this alley. And
I like traffic. I like traffic jams.
Yeah.
Traffic jams mean I'm getting paid.
Exactly. And so that's kind of like the common perception.
Yeah.
But then if you go down and look at what are the tools to be able to make modern construction a reality, excavators are at the top of the list. Mm-hmm. And so how do you think of, like, how do you segment and help understand people that don't know anything about the excavation market? How do you help them think about the market? So you've been obviously, taking the engineering experience aside, when you were a manager for CAT and you were managing, budgets and sales, etc. You must have learned, an incredible wealth of experience with that. And so how do you help people that don't know anything to make sense of this? So how do you give them like a crash course? Allowed to get my audience, really hooked on this in this industry, because I think it's one of the most interesting ones in the build forward.
Yeah, it's a great question. I'll tell you the mistake I made in the beginning. The mistake I made in the beginning was that it was related to the size of the machine, right? Sure. And the way we are organized, the way most companies are organized is around the size of the machine, right? Because it's a design manufacturing synergy that they're looking for, right? You don't want to run a 90-ton excavator down the same assembly line that you run a 7-ton excavator down. So there are size synergies. And, but as I spent more and more time with customers, directly with customers, I learned that they didn't think about it that way. They thought about, the work they were doing. So, I think of, there are and it was kind of application oriented, right? So there are excavation customers that do, and those are the ones that we talk mostly about at DIG, and their job is they run a bucket most of the time, and they're loading material. They're either, as I mentioned earlier, they're either taking a site from greenfield to a near net shape, or they're loading, or they're in an aggregate environment, and or they're loading a hopper in a mining application. Their job is to move material from one place to the next. And that's a very common, application, 10 million machines, something like that worldwide. Then there are at the other end of the spectrum, there are customers that I think of as they do a wide variety of work with an excavator. They use it as a Swiss Army knife, right? It lifts. It might have a hammer on it for a little while. It has hydraulic circuitry so that it can run a shear or something like that. And then it digs too. It does excavation work too. It's a lifting machine. So instead of having a dedicated crane on site, don't tell the regulatory agencies this is going on out there, but it's really happening where we're using excavators to lift with. And you'll see in Europe in particular, regulatory requirements that enable that machine to be a safe lifting machine, like a crane, like the kinds of regulations we have around cranes. And then there's a spectrum across the middle of, as there are customers that, I do half the work I do is excavation, half the work I do is more general kind of contracting work. However, I think you'll find that the ones that are the most successful are the ones that have a real specialization, right? My job is moving dirt. My job is laying pipe in a trench. I mean, I do that better than anybody in the world. And that you'll find that they are specialized. They know their costs very well. Of course, they'll do whatever it takes to get the job done, but they're really focused in on what are they successful at. And then the other level of segmentation is, do I own it or do I rent it? And you'll find, I find customers that want to own everything, and I find customers that want to rent everything. If they think about the machine as an asset, they want to buy it. If they think about the machine as a cost, they want to rent it. And in fact, it seems to me that there's always a spectrum of what you own versus what you rent. If you can keep it fully utilized, the tendency is to own it. If you need it for peak shaving, or you can't keep the machine fully utilized, or you are moving from, one region to another to do work, then there's a lot more rental equipment involved.
This is actually, you touched on a point that I really want to go down into, because, in general, Brad Jacobs, United Rental, there's a bunch of giants in the US that live off of the rental business model. Yeah. And then we know that there's a bunch of very big, players and general contractors that will just own all of their equipment. But the share, it's ending the tilt on the left, because that's a lighter model, not very light, but still, that's a lighter model. Right. It's something that it's more enticing. So when was it that, so how does this relate back to Cat dealership business? And how does this, impact Cat's top line? Because the way that I see it is, those machines need to be produced, need to be manufactured, need to be distributed, need to be used, but maybe they don't need to be owned by all of the customers, and that might shrink the size of the number, might shrink the total number of machines. So how did Cat basically hit the wall of the rental revolution in the United States, which I believe started around
That's great. That's an excellent. So the heavy rents idea, arguably, and it's debatable, but I think it was invented by a gentleman whose name is Tom Hawthorne, the late great Tom Hawthorne. Tom was the dealer principal for Hawthorne Machinery, which is Southern California, San Diego. And then they also acquired some of those dots out in the Pacific, Hawaii, Maui, Guam, some places like that. But one of the things that Tom did was he wanted to, recognized that early on that some big machines were necessary for housing pad development in that part of the world, but also for waste handling. So he had 657, they wouldn't sell them. They had 657 scrapers that they would sell, that they would lease to the counties. And those jobs of those 657 was to open up the landfill at the beginning of the day and to close the landfill at night, because there are regulations around let's say the aroma around the landfill operations. And he recognized very early on that in both of those applications, if he rented the equipment to customers, that he could then sell it and still make a good margin on selling the used piece of equipment. So he was, and when he was renting them, everything was captive. It was a way for him to keep the parts and service business as well. And we could go, and I'm oversimplifying it tremendously, but that was Tom's vision of he was gonna rent down machines and then sell them. And that concept spread to the point where people forgot who invented it, frankly. That's fine. I don't think Tom probably cared when he was alive that he got credit for it, which he deserved. He doesn't care anymore. The family, I know the family very well. They're great people, and I know Tom very well too. He used to take me on fishing trips just so that he could keep me prisoner and beat me up about excavators. And then when he was done, then we would return from the fishing trip. That's a story for another time, but that's seriously what Tom would do. That model worked really well for Cat dealers. And it also worked very well for Caterpillar, the parent company, because you're right. I think that meant that there were fewer machines in play, fewer machines being built, but it also gives OEMs the opportunity to own the parts and service business. If the channel for distributing machines is the dealer, is the OEM specific dealer, then you have the opportunity to control the parts and service business. And that's ultimately what you want. You want the machine in the field because of the annuity it creates, right? It's not the best analogy, but it's the razor blade analogy, right? I sell we sell the handle, and then, we make a tiny bit of profit on that. And then we sell the blades and we make a lot of money on that. And I think that's kind of the model that OEMs are following, and the reason that it works.
And then so it's interesting because a lot of people, so I've met quite a few founders that are trying to create they call it a light OEM approach to new heavy equipment, right? So they're creating their own excavator of a certain size, and they basically want to sell them, but then they want to try to fit in kind of like off the shelf parts and distribute them to kind of like white label dealerships all around the US, and then try to run this lean operation. But when you really dig down in diligence with them, you realize there's a bunch of things that they lack. And one of them is, scale on the manufacturing side. You're like, okay, you just can't get manufacturing for cheaper than that would get, just because of the sheer size of volume that they process. Then what happens next is that you need a trusted set of maintenance partners.
That's it.
It's like,
that's it.
It's break down really, really often.
Yeah.
And so you need to have people ready to serve. Otherwise, a customer will never rebuy again.
It is such a relationship business, Gabe. Yeah. And everywhere in the world. I mean, you have to trust that because look, we're not putting these on the highway. We are putting these machines in nasty applications, right? And I always told my engineering teams, I said, look, customers are going to find ways to break your machines that you never dreamt possible. They're going to find applications you didn't dream of, and they're going to break it. And when that happens, there's a dealer network that will take care of the customer first and come back to the OEM and ask for help later. And those are the kinds of relationships that really make the best OEMs win. Is it possible to do the light? It's kind of a Tesla model, right? We're going to order the car online, and it's going to be so reliable that we don't have to have a big dealer network.
Maybe works on the highway in the dirt.
Hard, really hard. It's really going to be challenging. Yeah. I think that's a threat. If I'm doing a traditional SWOT analysis, the strengths, weaknesses, opportunity, threat kind of thing, it's certainly a threat that Caterpillar dealers or any OEM dealers are looking at. However, how do you attack that threat? By just maintaining the relationships that you've got and just, lavishing care on the customers that you have. It's, remember, it's 10 times easier to keep a customer than it is to get a new one.
Oh yeah, for sure. And then, it goes for every single industry.
It does.
So what's wrong in the industry today? So what is it that you think is both on the utilization side, like both on the customer side, and that I guess is going to be the focus of our conversation when we talk about what you're building right now. But I also want to ask you if you think there's something else that needs to be fixed, that it's like a prime issue for big OEMs like Cat. What is it that it's, to be solved in the industry that hits, this new age with everything that goes with it, digital age, volatility in construction. There's a bunch of different parameters that can be really impactful on those businesses. So what is it that is?
Well, I don't know. I'd probably rephrase it a little bit. I'm not sure that it's wrong, but there are opportunities for improvement. And I think I may have said earlier that the price of dirt, I've said this a lot. I say this a lot. The price of dirt hasn't changed in 100 years. If you look at, if you think about, things that have not kept up with inflation, the price of moving a yard or a cubic meter of dirt has not kept up with inflation. And so you've got, you have rising costs of fuel and operators and operator shortages. Yeah. I think if you're going to be successful, if we're going to continue to be successful, we're going to have to be a lot more efficient. That's the way I look at it. And so I think that's, what we really need to get to be focused in on. How do we make it more efficient? And I think the other thing that's happening is there aren't a lot of young people who were so like I am. I love to sit in the seat of an excavator and make it work. I'm terrible at it, but I think it's fun. But I don't know. From a labor point of view, I think the labor shortage is arising from, I'll call it a fact, that fewer and fewer people want to operate this equipment. And that makes the labor pool more expensive, and even more important that they're well trained, that who we have are well trained, and that they produce as much as they can for as low as a cost as they can. I also think it opens the door for, more semi-autonomous and autonomous work. When we solve those problems, I think if I've got a machine that doesn't get tired at lunch, doesn't get tired, doesn't need a lunch break, I think that's an opportunity, Gabe, but it still feels like in construction that's some years away. We watch mining haulage units be automated first. They're the most predictable. It's the most predictable kind of course. The loading units in mining are coming next. We know where they're going to be for the next 10 years, 20 years. We know what the mine's going to look like. They're predictable, but man, a highway job, try to automate a 35-ton excavator on a highway job. That's a lot. There are a lot more, many more unforeseen variables at play that make that job of automating it extremely difficult. Yeah. So where I'm at is let's make operators, the operators let's make it more interesting for them. Let's train them well and let them, let's at least at this stage of the development of these machines, I want to focus in on the operators first. The algorithms that we're using, that we can use to teach, that we can use to make them better, hey, they'll be the heart of semi-autonomous machines and autonomous machines later. But for now, as in terms of where market acceptance is, I think making, focusing in on helping operators get a lot better, and they can be a lot better. They're good, but they can be a lot better. Is kind of what I see as one of the big opportunities. There are a lot of efficiency conversations we could be having. I think there's some studies, energy audits around machines, and Gabe, I'll quote it, and then I'll have to dig it up later and find it for you. But I think that a typical hydraulic excavator turns something on the order of 12% of the potential energy in diesel fuel into meaningful work. So the losses are about 88%. And that's just because, friction is your friend. Without friction, you can't excavate anything. But more friction than absolutely necessary, that just turns into heat. It's not useful work. It's just heat. And then, I'm going to quote it's a Volvo study. Volvo Construction did a terrific study. Did I just say that Volvo Construction did something terrific? I did, didn't I? That's going to be recorded. They did an excellent study of the variability in operator performance. I think it was 2013, 2014 where this study that they did. And actually there was an article published in For Construction Pros about that time. They looked at 80 operators and the variability of productivity, yards per hour, meters per hour, or tons per hour. That's the way I think of productivity in excavation. The variation among experienced and expert operators was 3x, 300%. So, here I am as a product developer spending, 9 digits on an excavator design program to get 5 to 10% improvement in productivity. And we have a 3x delta just based on operator skill level, operator training level. And then
told them.
Well, that's what we're trying. That's what we're doing at DIG Robotics. We're gonna solve that. And everybody thinks that we're gonna automate it because we've got robotics in our name. But let me finish. Let me give you a couple more numbers too, and then we'll get into how we think we can solve that. If you look at the efficiency numbers, the variation is 150%. So then I think of efficiency in excavation as tons or volume per unit of fuel burned. So the efficiency delta is 150%, 1.5x. If you put infrequent operators in these numbers, that 3x productivity variation turns into 7x. It's like that's not borderline unbelievable. That's just flat out unbelievable that we have that much variation in operator skill, but we do. And then the efficiency numbers with that pool added is 3x. It's 300%. So imagine a site manager who's trying to control an excavation and determine whether or not he's going to be on schedule. He or she's going to be on schedule. You've got operator variation of 3x. Am I going to be on schedule this week? Probably don't know. I wish I did, but I don't know, because the standard deviation among these operators of how they are able to manage machines is so high. So my outcome just isn't predictable enough. So to me, from a excavation, and I think this goes for, it's really an issue with excavators, because let's face it, these are complicated machines to operate. It takes a great deal of hand-eye coordination, Gabe, that you have that I don't, to make these machines run well. So here's what we're doing. And I said at the beginning that DIG Robotics is the intersection of kinematics, of 3D scanning, 3D imaging, and machine learning. So what we're doing, with my two co-founders, Dr. Oded Medina is I'll choose a wrong word. He's a savant. He's a kinematics savant. So he is one of these people that he has equations of motion in his head. It's amazing how his ability to describe and manage how machines move. So he's one of our co-founders who's brilliant. I'm probably underselling how brilliant he truly is. And then Noam Rotem is our CEO. The other co-founder in this is a serial entrepreneur. The two of them formed a company called Syracuse a couple of years ago. I shouldn't say a couple of years, 2019. And they developed what I think of as the Tesla autopilot for tower cranes. So there's a load on the ground. I want it in the air. There are conflicts, other machines in the area. There are wind conditions, and the operator could select the load and determine where he or she wanted the load, push the button, and it would automatically get it there. They sold that business off about 2 years ago to a crane rental company, and I always tease Noam that he should be driving a Bentley right now, but he's not. And then they immediately started thinking about what do they want to do next. And they both decided that they love the startup space and they wanted to focus in on motion control and excavation. And somehow, we're convinced that I'm the excavator guy that they wanted to co-found this business with them. You'll have to get Noam on and talk to him about how that happened. So what we're doing is, from a kinematics point of view, is we are able to calculate the exact best path for a bucket to follow for each and every one of the thousands of scoops in an excavation. So based on the topography, based on the material, based on the shape of the bucket, the geometry of the excavator, from an engineering point of view, we can calculate exactly the right path to follow. But we're also watching with 3D imaging what's going on in the bucket at all times, because shit happens out there. And so, as you have this theoretical load of the bucket, what we're doing is we're watching how the bucket actually loads. So we can respond in milliseconds to adjust. And if we have to deviate from the ideal path, to get a faster, more efficient load, we know exactly within milliseconds what to do. And then machine learning is where machine learning is being applied because, we'll do a decent job on bucket 1, but it will inform bucket 2, and both of them will inform bucket 3, and all of them will inform bucket 4, and so on. So what happens is each subsequent load is better than those that preceded it. So it's responding in real time to the material, the non-homogeneity of the material. If you break a bucket tooth, we know in milliseconds it's gone. If you hit a rock, we know it's there. So that's how we're doing this. We're able to take 20% of fuel out by following this minimum, I call it minimum energy path. It's a local, get into the mathematics of it. It's a local minimum, not an absolute. The minimum energy path is to just sit there and do nothing. But it's a local minimum, right? So to follow that path, we can reduce fuel. And then it turns out that local minimum is also a very fast way to get through the material. So we're getting 10% improvement in just tons per hour, and then a 20% reduction in fuel. One of our devices is on an old, I'm going to use a competitive. I'm not going to use Caterpillar again. It's on a Liebherr R984, which is what a vintage 95 through 99 machine, 100 metric ton machine. Dumb iron. So there are not a lot of sensors on this machine, but a really productive, robust machine. And we have the customer wanted to modernize that machine with our system. And the data is indicating we're able to meet those targets of reducing fuel and increasing productivity. And that's what we're trying to do. So I made a long story. I made a very long answer to a quick question, but that's what we're trying to do.
The image, I think it's giving the image of like the marginal improvement that you can get. It's actually a huge improvement. The marginal improvement in performance, actually a huge improvement on the cost side for the people that are operating this. Obviously, if you're not in the business or you haven't studied it, even just superficially, you don't know. But, fuel cost, together with maintenance costs, which actually derive from improper use of the excavator machines, are extremely heavy on the P&L, people that are operating and owning these machines. And so it's extremely important that you have the best efficiency and best performance that you can. But what you are hitting against is a skilled labor shortage of people that have done this for a living.
Right.
And so you get apprentice pilots, apprentice operators that are just there because they have to do the job and they know kind of how to do it, and they'll just be inefficient at it. And that will hit the top line.
Yeah.
As well as the bottom line of the company.
Yeah.
And
right.
So, but the question that I have for you is, to help our audience visualize it, how is it that we deliver those insights to the operators? So if we're not automating, how is it that we
So let me add something to your comments first, and then I'll answer your question. That Liebherr, for example, uses about 50,000 gallons of diesel fuel annually. So just in terms of putting it into perspective, what the costs are. So we're taking 10,000 gallons of diesel fuel out annually. Of that operation, and that's just the fuel cost. So that's the kinds of numbers we're talking about. So there are really relatively few parameters that have to be ideal when a bucket is moving through the dirt. There's a depth of the cut. So is your cut 6 inches deep or 2 feet deep? There's an ideal cut, and it varies by material. There's a rotation of the bucket. So all the way throughout that stroke, the bucket rotates, and there's a perfect angle for every point along the stroke. It's not just set it and forget it. It's almost, I've used the analogy, it's like a golf club. It's that there's two open and there's two closed. So two open means that you're putting a tremendous amount of pressure on the cutting edge and the bucket teeth. So you're trying to pry the bucket open, if you will. And then too closed means you're putting a tremendous amount of pressure on the back of the bucket. So in these abrasive applications, you'll see, you can walk onto a job site and you can see who has a tendency to close the bucket, because what happens is there's probably sacrificial material, wear material welded onto the back of the bucket, because they're wearing the backside so much that it's cheaper to weld on material, to weld on something that will wear off. It's cheaper to do that than it is to repair the bucket. But think about it. If you're lifting and moving that wear material every time, you're not moving material. You're just moving a heavier bucket all around all the time.
Yeah.
So there's that indirect cost as well. Then the other one is the net. So first variable is depth. Second variable is the rotation. Third variable is speed. Am I too fast? Am I too slow? It's pretty, you can really make a difference with speed. And then the fourth one is timing. There is a time when the bucket is full and you need to get out of the cut. And what most humans do is they respond to a really, really full bucket. And so the reinforcement that you're getting visually is, let's hog the bucket. Let's load the bucket as full as we could possibly get it. But the problem with that approach is it's too full in the sense that you can't carry it to the target. You can't carry the material to the target. So all that means is you're going to move the material twice. You pushed it around. You really didn't do anything productive with it. You're going to have to come back and get it later. So if you stay in the cut too long, which is the mistake that the vast majority of operators who can improve make, then all you're doing is burning fuel, and you're going to have to come back and do it again. There's also the tendency for novice operators to underfill the bucket. And that means, if you're loading trucks, you've got to come back for a fifth pass or, an extra pass. That's really expensive too in a day. But usually what's happening, Gabe, is they're pushing too long. They're getting a really full bucket, and they're burning fuel, putting wear and tear on the machine, and not getting the kind of productivity that they need to get, just because they're staying in the cut too long. One of the benefits of grade control, and I think one of the risks for DIG is that people will think of this as grade control. One of the risks of one of the things we observed, and the reason grade control works well, is because one of the most expensive things to do in excavation is to move material twice. If you dig too deep and you have to come back and lay the material back in and compact it before the real construction, I'm sorry, we characterize it that way, before construction starts, that's incredibly expensive. And so what companies like Trimble and Topcon and like a Hexagon are doing with grade control is they're defining the near net shape of what the green field should look like for construction to start. Yeah. And right. And so what they're doing is they're making sure that the operator doesn't dig outside of that near net shape, that desired near net shape envelope. Because if they dig outside of it, you got to bring material back. And again, that's really, really expensive. What we're doing is everything between the green field and the near net shape where you're free digging, we're focused on every scoop that's between the start and when grade control would take over, or when grade control technology would take over. And there's another great technology too, obstacle detection. We're not, if we were working with, a great company that's doing obstacle detection is Rod Radar. If there's an obstacle there, and we were working with that technology on the machine too, we would defer to it, and it would help the operator avoid the obstacle. Those are the expenses, right? If you hit an underground obstacle you didn't know was there, that's an expensive miss. And so you can see that's what we're focusing on. Did I answer your question? I rambled around there way too much, and I get excited about what we're doing.
Actually, you may have not answered my question, but
let's try it.
But you did give a lot of color. So what you are saying is the physical problem has a bunch of variables. The efficiency is a function of how deep you go, how fast you go, how you rotate your bucket. And you want to have sensors that look at what's happening, that can realize, okay, this is the state of the bucket. You want to have though, and that was my question, but you want to have a display, quote unquote, or something that can tell the operator what to do. And so my question to you guys is, do you basically equip the operator with an additional kind of like screen where they can see what are they doing wrong, or kind of like predict what the next move, the next move should be?
We do. So we've got a screen that has those 4 variables on it, and it kind of in a bar format that, here's where you are, and here's where you want to be. Okay. And for a novice operator, that can be continuous. You're too deep. It can really give them. It's instantaneous. Telling them, advising them on where they need to be. For more experienced operators, I think that would drive them insane. So what they're able to select is more of a trending type of analysis. You're trending. You could, over time, we're sensing that the system is sensing that you could be, if you were shallower in general, or you close the bucket sooner or later in general, that you could get better performance. So it's selectable.
And this is actually a great point, because what we know of construction robotic startups, so allow me to use that name just because it's in your,
it's fine.
It's name, fine. Which, by the way, I think it is definable as robotics, but in any case,
it is. I think it is too.
But the thing is, like, you need to know your customer so well in such a nuanced industry like construction. That you need to be able to adjust the augmentation of the workflow to the base level of skill of the operator. And so that basically goes for everything, right? So like we don't want to override. I mean, there's some applications when you want to override, but those are applications where basically for a fact that you're going to operate end to end in the best of ways. And then I think a more humble approach as you develop your technology into full automation. And I don't know if that's your vision. It's going to be my next question, by the way. Yeah. But, as you develop your vision towards something that's more automated, then you can slowly start to incorporate more and more steps that are automatically performed by the system. And so, for novices, it's just great. Just tell me what to do. And then for skilled ones, it's great that you tell me what I'm doing. And, and so these are the 2 distinctions. But then my question to you is, now that we put aside, okay, this is what DIG Robotics is doing today, what is your vision for the company? And, in whatever ambition level you want to share it, right? So I know that some founders are really protective of the ambition level of their company, and some others are just not. And so I want to try to, ask you, where do you sit?
I think I would characterize it this way. We want to be prepared to respond when the market is ready, when the excavation part of construction is ready for more and more automation. The algorithms we're developing, Gabe, would form the heart of semi-autonomy or full autonomy. And I think also would have impact on what we're seeing in terms of remote applications. One of the things that have always concerned me about remote, especially in an excavator, is if you're sitting, 100 miles away in an office and you can't feel in the seat of your pants what's going on the excavation, this kind of an algorithm could, very easily, alleviate that issue. So I think there's no question we're headed. Come on. We wouldn't have called ourselves DIG Robotics if we weren't thinking about more and more automation. But right now, what the market we think wants is, let's make my operator machine combination better. So we're applying the algorithms, what we know about kinematics, machine control, 3D scanning. We're applying that to making the machine operator combination far better than they're able to be without us. So that's the start. But yeah, there's no question. We're headed down that way. I'll tell you a quick story. And, I took control back in my deep, dark past. I tried to take control away from operators for a specific situation. My ears are tuned when I'm on a construction site to hear when a relief valve opens. And I hate that. When a relief, so what it means is, so when you reach the maximum operating pressure of any of the circuits on an excavator, relief will open. So what happens is it prevents the machine from tearing itself up, is what happens. And they're all set up this way, right? And you can hear it. It's usually a much higher pitched sound than the machine's making. I mean, you'll hear it when the bucket's really loaded, you'll hear this kind of, I think it's a scream. I've always called it a scream because I think the machine is screaming for help when it's doing that. So one of my bright ideas, one of my brilliant ideas was to, not allow the machine to do that. So do not allow the operator to cross relief. So what we would basically do is derate when the machine got close to relief, whether it would be in a line or whether it be system relief, we would derate. That was a really bad idea. I mean, I'm just going to tell you, that was a really, really bad idea, Gabe, because operators' ears are tuned to relief as well. And they realized that the way they were tuned is that if they're operating close to relief, they're maximizing the output of the machine. So every time the logic of the machine would take that control away, it would just make them really, really mad.
And this is nothing different than airplane mechanics, because when you're basically taking off and you're almost keeping, so sorry for the audience, we're doing this so technically, I don't care. I like it this way. But basically when you're lifting a plane, you want to maintain that. I don't want to go into specific. You want to stay away from the stall area of the wings, right?
Yeah.
What you're doing is you pull up, you try to stay obviously as far away from the stall as you can, but there was a system that Boeing implemented, the MCAS, I think it was called.
Yeah.
Basically pushing against the operator.
It nose down. Right.
Down. And so it was actually one of the causes of the fatal accidents of Boeing, that the pilots were not trained to that. They were trained to operate by ear. We want to call it like playing it by ear. So knowing, like just feeling the plane under the cloche, just simply, like this is not going in the stall, but the MCAS had a different margin and a different error rate. And so they were fighting against the system, and that's what actually brought down those planes.
Yeah.
And so I think that needs to be applied to a bunch of things. So operators know how to do stuff. You got to augment them, not impede their work. And so I love the thesis of the product that you're building, because it's really reflective of how things are, to be, how things are done in this industry. Like that's how it's done.
Yeah.
But you don't want to take full control. And then a different thing is actually, I want to bring back a piece of the discussion that you were bringing up before. You said, automation is starting from mining. And the reason is there's a more uniform operating field there. It's actually, you can plan things because you have a green field of things, and you can just dig. And in the end, if you're getting something wrong, you didn't screw up much because you're just digging, right? And above all, in the initial phases where you're really just digging from ground level, you have a lot of margin of error. You don't really care. And so that's where automation is starting.
Yeah.
One of the portfolio companies of Fundamental is actually Safe AI, that is retrofitting heavy equipment to do this. Now, there's an analogy with autonomous driving. The reason why I probably a bit contrarian, I don't think autonomous driving will actually take off completely and widely in the open in the next few years, is that I think what needs to be solved first is the closed fence autonomous driving. So there's a bunch of companies that are realizing, hey, how is it that we move trucks from one slot to the other in the yard, where basically there's no risk of hitting other cars. It's a very controlled environment. It's private property. I don't have to comply with many regulations. And so those are actually the markets that I think autonomous driving will take on first, before going into full FSD level 5 with everybody just looking at their phone while driving a car, right? So that's kind of like the same thing. So you want to start from a controlled environment, and you want to do it for B2B, where companies where this is just hitting the top line. And for them, it's so key not to hire these drivers anymore. It's so rare. And at the same time, you're doing that in a safe space. You're not, killing anyone by doing a mistake. You're just maybe damaging some cargo or whatever. And so I love the analogy here. Is that something that resounds back to you?
No, it does. It does. So I always think, so one of the things that there's a concept, we're all familiar with Maslow's hierarchy of needs, right? There's another concept called Maslow's hammer. And that's this idea that we all know about, that if you have a hammer, every problem's going to look like a nail.
Yes.
And so, right. So what you want to do is you want to make sure, I do autonomy, so everything ought to be autonomous. No. What you need to do is you need to recognize what customers need. And you started talking about what are their critical requirements of customers in construction. And you hit on number one, it's safety. That's, you know what? I don't care what your machine does or what I don't care. It has to be safe. That is number one. It's got to be safe for my people. Got to be safe for spectators, on and on and on. Right. Number two is reliability. Like if you've got the greatest lifting machine in the world, but it doesn't start when I turn the key on, what good is it? Right.
Yeah.
Number three is performance. You've got, and performance can have a very broad definition, right? Performance is, could be a lifting. It could be excavation. It just depends on what the job is. In fact, I had a Chinese customer tell me, really surprised me. He said, "You're the large excavator guy, right?" And I after I got over thinking that he was referring to my weight, he said, you run the large excavator business, right? And I said, yeah. And he said, if I didn't need a large excavator, I would buy a small one. I was like, duh, of course, because performance is really key. Then the next one is owning an operating cost. It's owning an operating cost is like, because we've been talking about efficiency and the price of dirt not moving. So, you got to deliver on the owning and operating cost piece. You've got to make me more cost effective no matter what. And that might be a performance enhancement at the same cost. That might mean that it's, there are pricing issues, there are fuel issues, there are maintenance issues. All that falls into O&O. And then the last one, the very last one, if you solve all those first four, the very last one is I want to be environmentally conscious.
Yeah.
That's the very last one. It's really important because we all drink the same water, breathe the same air, but you got to take care of the first four before you get to the last one. Before you
also
get to
to align incentives and be able to, to be able to implement some change that is positive outside of the P&L, you first need to have it hit the P&L.
Right.
And that's something that, many companies outside of 2021 didn't really understand.
Yeah. I had a customer tell me once, I need to be able to afford to be reliable, environmentally conscious. It can't not be affordable because I won't be here. Somebody else will be taking care of my customers.
And so I love this. And you know what I did love about this, Ken, is that this is probably not going to be the type of episode that, the non-technical person will love, but if you're even slightly interested in physics, if you're slightly interested in engineering and building hard stuff, this has been a mine of gold. And thanks a ton for that.
Thank you.
I have a last question here because we went a little bit over time and try to keep.
Oh yeah, sorry.
No, but I don't care. Again, I love it. I have one last question, which is I usually ask at the end of every episode, what is your advice for people building hard things? But given your incredibly deep expertise in heavy machinery, what do you suggest to a very small subset, on which I believe there might be a unicorn, of founders that are building right now in this space, in the heavy equipment space? If you had to give one piece of advice, one synthetic one, that it could just, help them, get a little bit more context and color from your, 30 plus year experience in the field, what would that be?
Focus on your customers' needs. Deliver your technology must deliver on your customers' needs, period. That's it.
As easy as that.
It is. It is. And, and then I think the second thing I'd say is innovation isn't linear. I mean, if you're planning to do this on a schedule, it's not going to happen. It is not linear. And so there's a resilience aspect you really, 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 really better love what you're doing, because there are some times it's just going to suck.
Yeah.
It is.
I feel like if I had to make a playlist of all the advices, they would really sound similar. It must be a reason that we've received in BitBuilders. So I love it. And Ken, thanks a ton for being here with us and taking the time. I'll let you go back to, building really incredible technology for excavators. Something that I'm pretty sure is more important than, chatting with me on a podcast. But I've had a ton of fun.
Gabe, this is great fun. I really enjoyed this, and I've been looking forward to it just because of some of the other episodes I've listened to. And thank you. I love the conversation. That's what I was hoping for, and we got it. So thank you very much.
Then let's organize a part 2 soon. And thanks again for being on. And it's been great.
Thank you so much.